Okay, what I'm going to do here is repeat the lab from week 8 and preview the lab for week 9. And we'll put that up there so the people who missed out on stuff, they can look at it again. They can get ready for the coming lab this week. So, as we said in lab, make sure you get your 2 assignments if you don't have those in. I know a bunch of you turned those in. Hard copies, take a picture, scan it, do something to get them into the Dropbox up on Blackboard. So last week we talked about ration balancing theory. What are we doing? So regardless of the ration balancing program, we need to first define the feeds or define the animals. Sometimes, depending on the ration balancing program, you'll define the feeds first. Sometimes you'll define the animals first. Doesn't matter. So we're going to focus on defining the feeds first. And when we're thinking about our feeds, we need to figure out the composition. So we either use book values or send things off for analysis. And we can think about that as the quality of our feed. So what are the measurements? What are we looking through? Inventory. When we're balancing rations, we need to consider inventory. How much feed do I have on hand? Can I get any more of it? How long does it have to last? So we want to balance rations with that in mind. That is certainly a challenge we've had for the last couple of years up at dairy. Didn't get a fourth cut in this year. Things are a little light. How are we going to make sure that our inventories are managed so they're going to last us till next summer, till next winter, which is what our goal is. So in this case, we're going to define the animal second. Normally in a ration balancing program, you're balancing for one animal at a time. And you're going to go through, you're going to describe that animal. How much does it weigh? What is it doing? Is it milking? Is it pregnant? Is it gaining weight? Is it losing weight? Put all that stuff in. How old is it? Is it full grown? Is it growing? And then each of those things has nutrients associated with it, from carbohydrates, energy, all the way to the micro minerals and vitamins. So you figure out what the animal's doing, and the computer will usually generate the nutrients associated with that. And a standard approach is you figure out the nutrients associated with maintenance, lactation, growth, pregnancy, activity, and then you add those up going through. The third step is to take what we learned in defining the feeds, defining the animals, and we want to define that interaction. So how do you make the feed go with the animals? There's a lot of equations underneath, depending on how much an animal eats, where what feed type it is will influence rates and pools of digestion, and all that is put together. Bigger lactating cows are going to have a faster turnover rate than our heifers. So that's going to influence the extraction of nutrients, the extraction of energy from those feeds. So when we're balancing, the first thing we want to do is balance for NDF first, as a rule. So we can't get any NDF from the body. It can't be stored in the body, so it has to be eaten. You can't pull it off her back from her body condition. We need to make sure that we get that fed properly for proper rumen function, proper rumen health, and rumination. We need that NDF there. So we're balancing, particularly for our lactating cows, we balance for our fiber requirement first. Some people say you take energy next and then protein after that. I tend to do both of those at the same time. We balance our energy feeds, corn, barley, wheat, oats, with our protein feeds, soybean meal, canola meal, linseed oil meal, fish meal, balance those two things together, get the right mix so both my energy and uh, proteins requirements are satisfied. Next, you get into minerals. Certainly, the macro minerals are going to be a couple pounds. We need to get those taken care of. And the last thing we do is add the ADE vitamin pack and make sure we get enough taken care of to get the job done. The last step, and again, we'll present these again as we move forward. We need to take a look at the ration. Just because it works mathematically doesn't mean it's the right ration. Now, ration balancing's come a long way. There's some checks and balances in there that never used to be there, but we got to think: is this ration possible? Does it match my inventories? Can I do what this ration calls for over an extended period of time? Are the ingredients in the right amounts? I got certain ingredients that we'll get to and discuss that there's upper limits associated with how much you can feed. Have we exceeded those upper limits in some way, shape, or form? So is it inventory possible? Is it guidelines, feeding rules possible? And then we need to think about, is it safe for the animal? Sometimes things will balance out and you look at it and you go, well, that's not enough forage to make sure the animal's healthy. So we need to think about that and just take a step back and say, does this ration make sense? Probably the last thing we want to check is the cost. Sometimes, especially when we're balancing our heifer rations, um, we're feeding a whole lot of grain, not enough forage, and that can get a ration a little bit too expensive. So for ration balancing, we're working with the substitution method. And in the substitution method, the number of nutrients you balance for must equal the number of feeds that you use. So you can imagine we're going to be doing our rations by hand to get a feel for what we're doing. You can imagine that 4, 5, 6 nutrients and that many feeds, it would get very, very tedious to do this by hand. So we're not going to go beyond 3 for this. So the nutrients we're going to balance for are dry matter intake. So how much dry matter intake does that animal need, and are we satisfying it? We're going to balance for energy intake. So today, or lab 8, we focus on the TDN as a percent of the dry matter as our energy measure. TDN is digestible NDF, digestible non-structural carbohydrate, digestible crude protein, and digestible fat times 2.25. That's how we get that percentage. We'll be using megacalories per pound from net energy after this coming week, our next set of rations we're going to move into. Crude protein is going to be our third nutrient. We want to make sure all 3 of those are balanced, and then we'll call that a balanced diet. So we've got 3 nutrients. We're going to need 3 feeds, and our feeds are going to be called the 1, 2, and 3 feeds. So that's we identifying which one goes in each category. So our 1 feed's going to be our forage. It's going to be low in energy, low in protein, and the lowest of the 3 in cost per pound of dry matter intake, or pound of dry matter. Our number 2 feed is going to be the energy feed. It's going to be high in energy by definition, but low in protein. It's going to cost a little bit more than our forages on a dry matter per pound basis. Our last feed that we're going to use is our protein feed. We'd expect it to be high in protein as it by definition, but usually our protein feeds are also high in energy, and they tend to cost the most out of these 3 different categories. So our 1 feed, 2 feed, and our 3 feed have specific places we're going to use them. So we got to make sure we put, when I give you a set of feeds, you got to take a long look at them and make sure that things are where they are, and you've assigned the values to the right feeds on some way, shape, or form. So we take our three nutrients and our three feeds and we attempt to balance ration. The substitution method, let me skip to the next slide. The substitution method is a step by step procedure. The thing that you need to get a feel for is how, when we take something out, put something in, how does the ration change? The reason I teach the substitution method is even when you get to a computer doing the math for you, you're still going to be doing the substitution method. What do I have to add to balance the ration? What do I have to subtract? And so we think about taking feeds out, feeds in, and we have to make sure that we substitute in a way that's going to get us to a balanced ration. So we're going to start with this simple substitution method. We're going to balance a ration only using feed 1. And then we're going to ask, does that satisfy dry matter intake, energy, and protein? If it doesn't, we're going to move on to our second ration, ration number 2, where we use feeds 1, our forage, and our feed 2, our energy feeds. We're going to ask, does that satisfy dry matter intake, energy, and protein? If the answer is no, we're going to continue on to our third ration, where we're going to use feeds 1, 2, and 3. And for the most part, we're going to use all 3 in our ration balancing to get that final balanced ration. So we're going to demonstrate a ration here a couple different ways. We're going to use hay, corn, and soybeans. So by definition, looking at the TDN and the crude protein, our hay is our number 1 feed. So that's our forage. Our corn is our number 2 feed, our energy feed, high in energy, low in protein. Soybean meal is going to be our protein feed, and we've got high in TDN, high in crude protein. And if we take a look at our different feeds here graphically, we can say that our hay, 1 pound of it, is 40% TDN, or it's got 4/10 of a pound of TDN in it. So each of these green circles represents 1/10 of a pound in that pound of hay. We look at the crude protein, it's our red dot for hay. We're 10%, so we've only got 1/10 of a pound of crude protein in that 1 pound allocation or amount of hay. If we look at corn and what 1 pound contains, we see that it's 80% TDN. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 dots here, each representing 1/10 of a pound. Each pound of corn has 8/10 of a pound of TDN. On a protein basis, we're the same as hay, 1 red dot representing 1/10 of a pound of crude protein. Our soybean meal, our feed number 3, if we look at 1 pound, 80% TDN, 50% crude protein. So every pound of soybean meal has 1, 2, 3, 4, 5, 6, 7, 8 green dots, each representing 1/10 of a pound. That 1/10 of a pound, or 8/10 of a pound, is the TDN in our soybean meal. So every pound of soybean meal has 8/10 of a pound of TDN. We look at our 50% crude protein, that means we're going to have half of that pound, or 5/10, or a half a pound of crude protein. So 1, 2, 3, 4, 5 red dots, each representing 1/10 of a pound. So you're saying, well, 8 and 5, those are going to add up to more than a pound. There's an overlap here. Some of that TDN could be used for energy, is very digestible, and that represents protein. So very high in protein, very highly digestible. So some of this 80% of TDN is a significant part of it is protein. So let's look at this ration substitution method graphically or in pictures. So I have a pile here. We're going to say that's 15 pounds of hay. So I go in, I put 15 pounds in a pile, and I ask, will that satisfy this cow's ration? And it turns out it doesn't. So we're going to be short on energy, short on protein. So I'm going to need to substitute and continue on to ration number 2. So what I do is I take out 5 pounds of hay and I bring back 5 pounds of corn. So 15 pounds of feed for dry matter intake, 10 pounds of hay, 10 pounds of corn, or no, 10 pounds of hay, 5 pounds of corn. Does that satisfy my ration yet? The answer is no, not yet. We're still short on protein. So I take one of my corn pounds out, I bring in my soybean meal, and we're going to show that we're going to have this pile of 10 pounds of hay, 4 pounds of corn, and 1 pound of soybean is going to be a balanced ration. So let's do it graphically or drawing figures this way. So I have my inputs. Up top here to the left, I've got my requirements. I've got 3 nutrients I need to balance for. Dry matter intake, 15 pounds, TDN, 8 pounds, crude protein, 1.9 pounds. That's what I need to balance this ration for this cow, this heifer that we're balancing a ration for. Right now, if I look at my hay, my corn, my soybean meal, note the color coding there, the tan, the yellow, the blue. I am not feeding any of those yet. If we look down here, this big square here on the left side in the middle from top to bottom is going to represent our dry matter intake. So I've got 1, 2, 3, 4, 5, all the way up to 15 pounds. So each of these columns under each of these is 1 pound of feed, and I can divide that into 10 equal parts or 10%. So the top is going to be energy, the bottom is going to be crude protein. So I've got 3 feeds I'm working with up here in the upper right. My feed 1 is hay. It's going to be low in TDN and low in crude protein. I've got my feed number 2 is corn, my energy feed, high in energy, low in protein. My feed number 3, my protein feed, is going to be soybean meal, high in energy, high in crude protein. So I take these analysis and I go down here, the next step down. These are representing individual pounds of the feedstuffs and how much TDN in green is in each pound. So my hay is 40% TDN. I've got 1, 2, 3, 4 green squares, so 4/10 of a pound of TDN in every pound of hay. Corn, 80% TDN, 1, 2, 3, 4, 5, 6, 7, 8 green squares, each representing 1/10 of a pound. We add those up. Every pound of corn's got 8/10 of a pound of TDN. The same with soybean, again, 80% crude protein. We count up our green squares. We've got 8 for 8/10 of a pound of TDN in every pound of soybean meal. We go down to the lower right. We have our crude protein illustrations by the pound. Again, feeds 1, 2, and 3, hay, corn, and soybean meal. Hay is 1/10 protein, 10% crude protein. So if the column represents 10 tenths, we've got one of those for hay for crude protein, one of those for corn for crude protein, and then our 50% soybean meal is going to have 1, 2, 3, 4, 5 red squares for a half pound or 5/10 of a pound of crude protein. So what we just went through is basically putting this into a drawing, putting it into a graphic format. So if we look down at the bottom here, we're going to do our first ration trial number 1. So what we're doing for the first ration is we're going to feed 15 pounds of hay. So you notice all the pounds up on the top here of this middle section on both sections, middle and bottom, is tan. So that means we're feeding 15 pounds of hay. So if we take the 1 pound over here on the right of hay, we copy that to each of these going through. We're going to have 4/10 of a pound of TDN for every pound I have. If I do 4 times 15, I'm going to get 60 squares, or so 60 squares, each one representing 1/10 of a pound. That's going to work out to 6 pounds of TDN in that 15 pounds of hay. So is that where we want to be for dry matter intake? Yes, we've fed 15 pounds. That's as much as you can eat. What about energy? Well, we've got 60 squares, each being 1/10. That adds up to 6 pounds. Our requirement up here at the top left is 8 pounds. So we are short on that. We also go down and look here. We are short on protein as well. Each pound of hay gives 1/10 of a pound, 15 squares, each 1/10 of a pound. That's going to be 1.5 pounds of crude protein. We need 1.9 pounds up here in the upper left. So, trial ration, looking at our tab down here, doesn't work. We need to move on to the next ration. So this is a pile of feed representation. We got 15 pounds of hay there. It's not getting the job done. We need to move on to ration number 2. So what we've done in ration number 2 is we've taken out 5 pounds of hay and replaced it with 5 pounds of corn. So in each of these tables here, you can see that our 11th, 12th, 13th, 14th, and 15th pound is now yellow, and therefore we've replaced our hay with corn. So how's this ration look? So over here, by taking out a pound of hay and replacing it with a pound of corn, each time I do that substitution, I gain 1, 2, 3, 4 pounds of corn, 4 squares of corn, so that's 4/10. So if I take out a pound of hay and put a pound of corn into the pile, that exchange increases the TDN in the pile by 4/10 of a pound. I do that 5 times. Each time I have 4/10, I'm going to add 2 pounds of TDN to the pile. So if I look at my left-hand table here for energy, I go through, I see that I've got here on the right side of that, I've got 80 squares. Each of those squares represents 1/10 of a pound in green here. So I've got 80 green squares. Each is 1/10 of a pound. If I figure out how many pounds that is, that's 8 pounds of TDN. I have now satisfied up here in the left my TDN requirement by making that substitution. Taking hay out of the pile, putting corn back into the pile. So I'm okay for dry matter intake. I'm okay for TDN. What about protein? Well, swapping corn for hay doesn't change the protein amount in the pile. Each pound, whether that's corn or hay, uh, brings in 1/10 of a pound of crude protein. I got 15/10 of a pound. That's going to work out to 1.5. I'm short 4/10 of a pound still. So trial ration doesn't work. 2 doesn't work. I need to move on to 3. So this is our representation of that. There, we've taken out 5 pounds of hay. We've added back, substituted in 5 pounds of corn. We check things. We're still short on protein. So we're going to move on. Now, we'll show you how we figure this out, but I'm going to take out 1 pound of corn and I'm going to bring in 1 pound of soybean meal. So I got the blue column all the way over the left on my TDN and my crude protein tables. So we know the TDN is still satisfied. I replaced corn with soybean, brought soybean in. It's got as many tenths of a pound of TDN as my corn. So substituting 1 pound for 1 pound is not going to change my TDN. I've got 80 squares. Each square is 1/10 of a pound. That works out to 8 pounds of TDN, which is where I want to be. So we go down the bottom of the page here, over on the right side of the column here. I take out 1 pound of corn. I bring in 1 pound of soybean meal. When I make that change, I'm going to increase the pile's crude protein content by 4 red squares. Each of those is 1/10 of a pound. I'm going to add, by taking out 1 corn pound, adding 1 soybean pound, I'm going to make that exchange and I'm going to increase the crude protein in the pile by 4/10 of a pound. So if we go through all our hay and our corn, each of those pounds has 1/10 of a pound of crude protein. My 1 pound of soybean meal has 5/10 of a pound in it. If I add that all up, I've got 19 squares, 19/10 of a pound. That works out to 1.9 pounds. And if I look up here, the upper left, my crude protein requirement, I've now satisfied that. So I've got 15 pounds of intake, 8 pounds of TDN, and 1.9 pounds of crude protein. The ration is now balanced. If I look at my pile, I've taken out 1 pound of corn, I've added 1 pound of soybean, and this pile that I've created should satisfy that heifer for today, at least on dry matter intake, energy, and crude protein. We've satisfied those requirements. So that's a graphic kind of drawing representation of what we're doing in ration balancing, combined with the pictures or the pictures of piles that we've done as well. So we're going to do our ration balancing. It's going to be a little bit more complicated just from a mathematical standpoint. Our numbers are not going to always be perfect and round using this form. So we're going to have 1 form for TDN, 1 form for net energy lactation and net energy maintenance and things like that. So these forms are designed to walk you through the process step by step. All of the instructions are written on the form telling you what to do. This is the form you will be provided with on the lab practical. I will give you the feeds. I will give you the cow's requirements. You're going to do the final calculations of what those total requirements are, and you're going to balance the ration. So you'll have this form. You just got to remember how to use it. So if we look at this form, the top part there, we put our name, our MID number, possibly a cow description in some way, shape, or form. So step 1, we determine the nutrient requirements in pounds per day for the animal described. So it's helpful to write down the animal being described. How big is it? What is it doing? Is it gaining weight? Is it producing milk? Is it pregnant? What do we do? So we calculate the needed dry matter intake for that animal, the pounds of TDN, and the pounds of crude protein. Step 2, we're going to find the nutrient composition of the feeds to be used. We'll use our feed tables for the most part, or I'll provide the analysis for you depending on the thing there. So the first column on the left there is the reference number. That refers to the feed number, the row number in your feed tables in the thing we handed out. Feed number, you're going to have to decide which feeds are the 1 feed, the 2 feed, and the 3 feed. You're going to have to collect the information, dry matter percent, TDN is a percent of the dry matter, crude protein as a percent of the dry matter. So you have your givens. We proceed then to balance our ration. So this is a cheat sheet that helps you set things up. You should have this up on Blackboard. It's the same as last year, so I didn't update it. You can feel better. You can write 2020 up in the MID spot. So we take the information that we've collected and we move it to the appropriate places there. So we take the things that are circled, we follow the arrows and put them down as we move through. So step 3, we're going to balance for dry matter intake or do our trial ration number 1 with just feed 1. So we'll go over this again. We got through this first page with our sample ration. We'll do a couple other examples and then we're going to let you do your homework going next week. So we start with feed 1. That's our hay. We're going to figure out the dry matter intake pounds. So we'll pull those down. That information will multiply through dry matter intake times TDN percent divided by 100 will give us the pounds of TDN in that pile of hay. We'll compare those to requirements and then we'll figure out if we're under or over. In this first step, you should always have your dry matter intakes satisfied because you're basically taking as much feed as she'll eat, her dry matter intake of feed 1, so that over under should be 0. We compare the amount of TDN in our feed 1 pounds. We compare that to what's required. And if we have a negative number, we need to continue on. Step 3, we got to figure out how to substitute. So this bottom half of the page is figuring out the substitution. And we do this in a step-by-step mathematical approach. So we figure out the energy in 1 pound of feed 2. So feed 2 is corn. It's 80% TDN. That means there's 0.8 of a pound there. So we'll put that in that blank. We'll put the energy in 1 pound of feed in the next blank. And then we can calculate our gain by subtracting the 2. So the gain is if I put my feed 2 in, I take feed 1 out. How much do I gain? How many pounds do I gain each time I do that? So we've got our gain. We're going to use that to figure out how much we still need. And we take what we needed, we divide by the gain, and then we get our feed. Amount of feed 2 we have to substitute in. So how much of feed 1 do we have to remove? How much of feed 2 do we have to add in? So to figure out what our feed 1 use is, we take our dry matter intake requirement, we subtract the amount of feed 2 we've just figured out, and then we have our new pound of feed 1. So this is as far as we got. In the last lab, we'll figure it out or move it out here. So our cheat sheet tells us how to move this information down. So where do we get our weight per pound? We're going to take those TDN numbers, divide by 100, and that'll give us our feed per pound or energy TDN per pound, where things go through. One of the things we need to do, usually we have a negative TDN number. We have to, so that's how much we're short. So if we're going to say how much is still needed down here, the second line from the bottom, the second step from the bottom, we need to turn that to a positive number to figure things out. Bring down our dry matter intake, slide our 2 down to figure out 3. So if you've got these forms, I usually print one side, front side. If you're printing out same, you might keep them on separate sheets of paper. So ration 1 wasn't satisfied. We need to go on to ration 2. We take our 2 feeds in our example. We did the hay and corn. We figure out from the bottom of the previous page how much of each we need in our mix to get the job done. We bring our TDN percents over. We multiply dry matter intake of each component times its percent TDN to give us pounds TDN here in the middle. We take our dry matter intake times our crude protein divided by 100, and then that gives us our crude protein pounds. We total everything up of the 2 feeds, what they're providing. We compare that to requirements and see where we are. So in this example, we were still short on protein, so we need to proceed to step 6. So step 6, balance for protein by first determining the gain in protein in pounds by substituting 1 pound of feed 3 for 1 pound of feed 2, and second by determining the amount of feed 3 to make up the protein deficit. So we're looking at how much protein is in 1 pound of feed 3, and we're going to subtract the amount of protein in feed 2. So in our example, each pound of soybean meal has a half pound there, so we're putting 0.05 pound of protein in our corn, our feed 2, 1/10. So the gain from substituting 1 from 1, if I take out 1 pound of corn, I put back 1 pound of soybean meal, my pile gains 4/10 of a pound of crude protein. So how much in each pound? Subtract, get the difference, and that's our gain. We bring down the crude protein still needed. We figure out to bring down the gain from the line above, and then we figure out how many pounds we need to substitute to get the job done. So here's how we slide everything down. In case you weren't following that, keep these cheat sheets handy until you get the hang of it, but how everything goes down from one blank to the next. So our next step is to balance our third ration. So step 7, confirm balance for TDN, dry matter intake, TDN, and crude protein, or we do our third ration with feeds 1, 2, and 3. So we have all 3 feeds here: 1 hay, 2 corn, 3 soybean meal. We go through, do the math. It should balance out. Step 8 is we are converting the ration on a dry matter basis to an as-fed basis. So we bring down the amounts of feed we use, our feed things. We take our dry matter percentage. Dry matter pounds divided by dry matter percentage is going to give us ad-fed pounds. So always remember, as-fed pounds is going to be bigger. We're adding the water in. So make sure that you have a bigger number over on the side there. So again, all the things that we need to do to move things around. So you can basically take the feed 1 from the top of the page. You can copy that in that row in ration 3. It's exactly the same. We bring down our new feed weights of feed 2 and feed 3. We're going to do our multiplication going across, do our totals, pull our requirements from step 1, and hopefully we come up to something that's balanced. So if we go through and put numbers on what we did, so we've got our example here that we did both from a photograph and then from a drawing. So we're saying a 750 pound animal gaining a pound a day, assuming 2% of body weight for dry matter intake. So dry matter intake, 2% of 750 is 15 pounds. We're going to give you that she needs 8 pounds of TDN and 1.9 pounds of crude protein. So we've got our 3 feeds that are feeding with. We're identifying the feed numbers associated with those. So we need to make sure that we have everything in the right place. Make sure that everything matches, that our feed 1 is in fact a feed 1, low protein, low energy. Feed 2, our energy feed, high in energy, low in crude protein. Soybean meal, high in energy, high in crude protein. We do that first trial ration using only hay. We add 15 pounds of hay. That's going to match the requirement. The difference between the two is 0. Our hay is 40% TDN as we work our step 3. And we multiply 0.4 times 15, we get 6 pounds. If we compare that to requirement, we are 2 pounds short. So we're short, we have to keep going. So we need to prep for the next step. In step 4, balance energy by first determining the gain in energy, TDN, by substituting 1 pound of feed 2 for 1 pound of feed 1. Second, by determining the amount of feed 2 that will make up the energy deficit. So we're bringing down feed 2, 80% TDN, so 1 pound is going to have 0.8 pounds of TDN. Our feed 1, we're going to subtract the amount of TDN in 1 pound of feed 1, so 0.4. The difference between the two, 0.8 minus 0.4, is 0.4. I bring the fact I'm 2 pounds of TDN short. I bring that down to the blank for the amount of TDN still needed. I bring down from the line above the gain, so is 0.4. Every time I take 1 pound of feed 1 out, I put our hay out, I put back 1 pound of corn, the pile gains 4/10 of a pound. So I need to do this substitution enough times to make up that 2 pound deficit. And our answer is I need 5 pounds of feed to be substituted in. So we take our dry matter here, the bottom line, dry matter intake minus I need 5 pounds of feed 2 to make up the energy difference. That's going to leave me with 10 pounds of hay still in the pile. Continuing on to step 5. So we were short on TDN. We got to balance things out. So from the previous page, I have 10 pounds of hay, 5 pounds of corn. If we figure that out for dry matter intake, again, we are 0 on that. I pull my composition, my TDN as a percent of the dry matter, crude protein as a percent of the dry matter from the previous page. So hay, 40% TDN, divide that by 100, multiply by 10 pounds of dry matter intakes. From my hay, I've got 4 pounds of TDN. Corn, 5 pounds, 80% TDN. I divide that by 100, I got 0.8 pounds of TDN for every pound. I multiply by my 5 pounds. That's going to give me 4 pounds of TDN. So 4 pounds plus 4 pounds gives us 8 pounds. That matches our requirement. So the difference between total provided in the pile and the requirements is 0. They are meeting requirements. Hay, we've got 10% crude protein. Corn is the same. So I multiply by 0.1 my pounds. I get 1 pound of crude protein from the hay, 0.5 pounds of crude protein from the corn. I add those up. We are at 1.5 pounds. My requirement is 1.9 pounds. I'm 4/10 of a pound short. So that's beyond the 10% difference. So we need to continue on. So step 6, balance protein by determining the gain in pounds by substituting 1 pound of feed 3 for 1 pound of feed 2, and then determine the amount of feed 3 we're going to need to make up our protein deficit. So for every pound of feed 3, we've got a half pound of crude protein in that pound. Feed 2, we're 1/10 of a pound for every pound of corn. So if I take 1 pound of corn out, I put back 1 pound of soybean. Every time I make that swap, I'm going to gain 0.4 pounds. So we do the math, 0.5 minus 0.1 is going to give us 0.4 pounds of gain for substituting pound for pound. I need 4/10 of a pound. I divide that by my gain of 4/10 of a pound every time I make the substitution. That tells me I need to substitute in 1 pound of feed 3 to make this ration work. So I've got 5 pounds of feed from up in my ration 2 there, of feed 2, 5 pounds. I bring down my 1 pound of feed 3 that I need. 5 minus 1 gives me a new amount of feed 2 as 4 pounds. So I move on to ration number 3 because 1 and 2 didn't work. So step 7, confirm the balance of dry matter intake, TDN, and crude protein, or run trial ration 3 with feeds 1, 2, and 3. So my amounts: hay 10 pounds, corn 4 pounds, soybean meal 1 pound. TDN as a percentage of the dry matter, TDN as a percent, or crude protein as a percentage of the dry matter are given on the step 2 on the previous page. I go through, I do the math. 10 pounds of hay contains 4 pounds of TDN, 1 pound of crude protein. I can copy that from the ration 2 at the top. That's the same. We've lowered our corn from 5 to 4. Soybean meal is added at 1 pound. So corn, 4 pounds of that multiplied by 0.8 is going to give you 3.2 pounds of TDN. And we multiply by 0.1 or 10%. That's going to give us 0.4 pounds of crude protein from the corn. Soybean meal, we're going to do 1 pound in this ration. 80% crude, 80% TDN is going to give us 0.8 of a pound of TDN. Our 50% crude protein times our 1 pound is going to give us a half pound of crude protein from that soybean meal. In this case, because I lined everything up perfect, so swaps were perfect, we're going to have zeros all the way across. Our goal is to find something plus or minus 5% is usually our goal. So figuring if we're within 5%, the errors in the rest of the thing are going to be greater than that 5%. So we need to check that there. Most of the time, those numbers are going to be pretty close to 0. Step 8, at the bottom of the page, convert dry matter of balanced ration to as-fed pounds. So I take my 3 feeds, my amounts: 10 pounds of hay, 4 pounds of corn, 1 pound of soybean meal, gives us 15 pounds of dry matter. All these ingredients are dry. We multiply or divide by 0.9 in each case. The dry matter percent or proportion is 0.9. So every pound of dry matter has 9/10 of a pound of dry matter. So 1/10 of a pound of water. So we take the amount, we divide by the dry matter percent divided by 100. So in this case, dividing everything by 0.9 is going to give me 11.1 pounds of hay on an as-fed basis, 4.4 pounds of crude protein, and 1.1 pounds of soybean meal for a grand total of 16.6 pounds that we're going to push into a pile and feed our heifer with. So again, remember, you need an as-fed number. It's got to be greater than the dry matter number. So divide through on that and make sure you get that bigger number.